Hey everybody, today we're starting a new unit that puts together the three other pieces we've done this semester. So we're putting together the electricity from the beginning, the magnetism kind of from the middle, and the waves we just did to make electromagnetic waves. One of the common electromagnetic waves that you experience all the time, of course, is light, something that we can't live without. So even though this title is called electromagnetic waves, it turns out that light is more complicated than that. And so we're going to start out with an exploratory kind of look at what's called the wave particle model of light, because light has actually a couple characteristics of being both waves and particles. And so we're going to explore both of those sides of things. And we're starting out with kind of the evidence that we have that light is a wave. And so down underneath here, it begins with some basics about kind of what we know and some generalized questions about waves and particles. And as we go a little bit deeper, I have a short video that's here. It's about 9 minutes long, made by Veritasium, and it's quite good. It starts out with what is light. At the very least, I'd like you to watch kind of what people have to say about light, and recognizing that light is a challenging and complicated subject. And so if you were to kind of person on the street interview, there's some really intriguing answers that people give. Feel free to watch the whole video if you would like. It does go a little deeper into what's going on, and it'll help to set you up for the questions below. Question number 3 talks about a hallmark feature of waves being this interference. And we're going to be looking at this in terms of two sources that are making ripples kind of in a pond. And down below on question number kind of 3A here, I ask you to go back and to edit this graphic. And you can do that by double clicking on the graphic itself and then going through and editing that and then save and close. So that's the part there. Going a little deeper on number 4, if you're in class with me, then you will be using a tuning fork directly. But if you are at home, you can go ahead and watch this video demonstration here of what it sounds like if you take a tuning fork and you rotate it near your ear. We're going to record our observations, and then we're going to look to see kind of what we know about waves and how that interacts. Number 5 is using a simulation put out by FET, which is quite good. And the question starts out, is light a wave? So give me your honest answer to that. And then we're going to start playing in the simulation, looking at interference and diffraction, which are both principles that waves hold. So the question is, does light cause interference and diffraction? And if it does, then we can go ahead and have some evidence that maybe light is really a wave. So we'll play with the simulation. There's some information about it here. The next piece is kind of in your own home or in the classroom, taking a look at a light source by squinting your eyes. You can also do this by holding your fingers up with creating a very small slit between your fingers and looking through it. But if you have a single bright light source in a relatively dim room, you can see the same kind of effects that are going to be happening. So there's some guiding principles here. And then last but not least, we're going back to the simulation. We're going to look at one slit and then double slits, which are kind of outlined in the original Veritasium video. But we'll look at the pattern as to what's actually happening inside of that. So hopefully this will be a good introduction to kind of the principles of waves and how they relate to light. I hope you enjoy kind of going through this and learning a little bit about kind of what is light from the waves perspective. All right, good luck on the assignment, and I will see you next week. Adios.